Welcome to Your Cyber Path, the podcast that helps you get your dream cybersecurity job by sharing the secrets of experienced hiring managers and top cybersecurity professionals with you. Now, on to the show.
Really what we want to do with the rest of our time here is kind of go through a little bit of mock interviews, because most of our listeners are either looking for a job, trying to get a promotion at their job, trying to switch into the career field or something like that. And that means at some point they're going to get questions in an interview asking them about confidentiality. But normally it's not going to be as simple as, Kip, what does confidentiality mean to you?
Correct.
Instead, you might get a question like, let's say, Kip, what does it mean when there's that little green lock next to the URL in your browser when you go to yourcyberpath.com? And then you're going to have to give an answer that's going to be, 1 to 3 minutes long that explains what that means. So we're going to do that right now, and I'm going to put Kip on the spot. So Kip, put on your interviewee hat. I'm your hiring manager. I'm interviewing you for this job. We're in your technical interview, and I ask you, Kip, wannabe cybersecurity analyst, tell me, what does it mean when there's that little green lock in the URL in your browser?
Jason, thanks for asking. Listen, that little green lock is really important because that's all about encryption. And that little green lock says a lot of things about the connection that you just made to a web server that corresponds to the URL that you typed into the browser bar. And without getting into a lot of ones and zeros, I would just like you to know that I'm aware that there's a key exchange. There's a cryptographic handshake between my browser and the web server. And during that key exchange, what's happening is that they're agreeing on a number of things like what kind of algorithm can my browser handle? Like, what's the most secure algorithm can my browser handle? What key sizes can my browser handle? Because usually a web server can handle a lot of really high-end encryption, but not every web browser can. So there's a bunch of protocols that are going on in there, and then eventually a key size and an algorithm is chosen, and and then we can start talking to each other with a nice encrypted tunnel between us, and that will persist for as long as we want to talk to each other. And all that's happening in the background, it's all automatic. We don't have to worry about it. But sometimes we'll get an error message because something's not quite right. Maybe the web server is using a self-signed certificate, which isn't considered to be as trustworthy as one that's signed by a certificate authority. And so we might get a weird error message. And then, especially like with Firefox, there'll be an ominous warning message that says, hey, this site isn't secure. Are you sure you want to do this? And you really should pay attention and see what's going on. But if you've ever looked inside of a digital certificate, it could be very confusing if you don't know how to decode it. So I don't want to go to that level of detail, if that's okay.
I think that's a good answer, right? And again, depending on the job you're applying for, they may want more technical details or less. For example, if I'm hiring you to be a security engineer or a system administrator, and you're going to be configuring our web server to be able to give you that little lock, right? I may ask the question a little bit different to say, I want you to tell me those technical details, right? And in those cases, if I was answering that question, I wanted the more technical answer, I would say, well, first, when a user is going to yourcyberpath.com, it first checks what is the domain name, and it goes to that CA. It gets a copy of that digital certificate, which is the public key certificate. Using that public key certificate, I'm going to pick a random number. I'm going to encrypt it, and then I'm going to send it over to the server. The server then uses its private key to be able to decrypt that. And when it does that, we now have a shared secret that we have, this random number that I chose, that only I know because I chose it, and the server can only know it because they have the private key, and only the private key can decrypt a message encrypted with a public key. And so now that we have that, we can then create a synchronous tunnel using symmetric key encryption, using that new random code. And I could go into all the different details that we just talked about, right? But again, the whole idea is you want to kind of practice an answer that gives you, 1 to 3 minutes, because that's what the hiring manager is looking to hear. They want to hear really quickly that you know what you're talking about, either on a technical side or the higher theory side like Kip presented. And both those would be appropriate depending on the job you're applying for. Yeah. So I want to give you kind of an example like that. Okay, Kip, I put you on the spot. You're trying to put me on the spot.
Oh, okay. So you might also get a question like this. So Jason, how could you use encryption to securely erase the contents of a hard disk or an SSD that you don't want anymore? Let's say you're going to dispose of that piece of hardware and you don't want any sensitive data left on it. How would you use encryption to deal with that situation?
Thank you for that question. That's a really great question, Kip, because most people think about encryption being used to create confidentiality of data, and they don't think about it as a data destruction technique. But you can use encryption to do what's known as a secure erase. With a secure erase, you're going to encrypt the hard drive. And then when you no longer need that hard drive, you can simply erase or zeroize that key that you used to decrypt the hard drive. Without that key, you're not going to be able to read anything on the hard drive. So all the data forensics in the world isn't going to help you, because you'd still be able to recover the data even if you formatted the drive or wiped the drive, but that thing that you're recovering is still encrypted. And so without that key, you can't decrypt it and you can't read it. So the only way to be able to read that would be to either wait for computers to get much faster, where you can then decrypt something using brute force on AES 256, which as the time of this recording or as the time of this interview doesn't exist. Or you can, you basically would have to try to guess the key to be able to unencrypt the drive. But otherwise, there's really no way to get the data. And so this is a really secure way to be able to delete data. And especially for those of us working in a cloud environment, we always want to use encryption on the drive that we're using, because these drives are actually just virtual drives that are existing on a physical server somewhere in the cloud that I don't have access to. So by using the encryption, whenever I erase that key, I now have protected all those cloud resources from anybody else seeing them when those drives are being reprovisioned for another company. And so that's kind of the way I would attack that type of a question.
Yeah, that's great. I want to also ask you about a little turn of phrase, crypto shredding. Have you ever heard of that?
Yes. Yeah. So crypto shredding is kind of the off the cuff nomenclature that people use for this term of secure erase, right? So crypto shredding is exactly that, right? You are basically shredding or deleting or zeroizing that key. And so in some of the environments I've worked in the DoD, we actually used a physical key. And that physical key would have to be plugged into the machine for it to be able to decrypt the drive and be able to read it. If you destroy that key with a hammer, or burn it or incinerate it or whatever you do with it, that drive is now useless to you. And so that's really what we're talking about. We're talking about crypto shredding is shredding the key, not the encryption itself.
Correct. And it's much faster, right? Because to zeroize a 1 terabyte drive using traditional methods would take forever. It's so much easier and faster to just shred the key and get on with your life. Okay, cool. I just want to make sure people knew that little piece of jargon.
Yeah, definitely. That was definitely a good one. And then we'll do one more interview question style thing here.
Okay.
And I'm gonna throw it back in your court here. So Kip, Kip the interviewee, I want you to tell me how you can protect data as it's being transmitted over the public internet. And I want you to give me a couple of different ways.
Sure. Well, it's going to depend on a lot on the protocols that you have available, and also on the systems on either end of the data exchange. So, for example, if you can use HTTPS, then or HTTP, then you can use transport layer security (TLS) to encrypt the connection. That's one way to do it. If you have more like a site-to-site connection between two networks, then you want to bulk encrypt everything. So you might have a site-to-site VPN, or virtual private network. Or you might have an individual who wants to get remote access to a trusted network or an enclave. They could use a VPN also, but that would be a client to VPN concentrator type connection, right? So not a bulk connection between two sites, but just between one node and a network. So there's some examples. You could even take a file, you could encrypt it using pretty good privacy or new privacy guard, GPG or PGP. And then you could take that encrypted file, you could attach it to an email. You can send the email in the clear, but the attachment's going to be encrypted. Or you could push that encrypted attachment over FTP, file transfer protocol, which is completely in the clear, but the file, because it's encrypted, would not be understandable by anybody who might intercept it. So there are some ideas. One of those might work.
Yeah, definitely. All of those are great suggestions. And, even when you mention FTP, my mind's thinking, well, FTP is not secure, which you said. And so you can have this encrypted file going over FTP, or you can actually encrypt the entire connection when you're using FTP by using SFTP or FTPS.